Hello, I'm Lenny Weiss. I'm one of the emergency physicians here at University of Pittsburgh, UPMC. Also have a big role with our emergency response service, emergency medical services in the city, and our critical care helicopter service, Stat Medevac. So what I wanted to discuss are the importance of implementing technology in emergency response services. If we were to have body sensors on a person that was either at risk or perhaps everyone that's alive, and that body sensor detected some change in their physiology or their positioning, perhaps that could alert a system and get a 911 response going so an ambulance can come to their aid. This could be positional or acceleration based. So if someone's upright or walking normally and all of a sudden they fall down and they're now on the ground, have a sudden jolt, they stop moving normally, they stop breathing, perhaps this body sensor could actually detect that. The other thing is perhaps it could measure their heart rhythm and their body, their actual EKG rhythm. And if this detected, just like a pacemaker, some abnormal beat, perhaps that could send a signal to the emergency responders to look for help. Another very important aspect of emergency response and emergency services and its relationship with technology is natural language processing. We use a lot of communication modes such as cell phone, radio, to communicate with each other. And in any emergency response system, communication is one of the most vulnerable and sensitive aspects. It's something that we have to make sure has a very robust standard and system and infrastructure.
In the NLP portion of our project, we decided to create a simple script using basic Python libraries that allows the user to either process a live audio recording or previously recorded audio file. The example you see on your screen right now is an example using a previously recorded sample 911 call. As you can see, the program is able to process the audio and present relevant information, such as the location of the patient, as well as the patient's medical condition. I can also run the script and say something such as, "Someone across the street is going into cardiac arrest right now." Once I stop the script, the program is able to process it and once again pull out the relevant phrase. While this model is fairly naive, as it simply searches for words and pulls out the surrounding phrases, we believe it is very open to a lot of future work, especially for natural language processing and machine learning experts.
And finally, one of the other very important aspects for the project is how to detect movements and changes in a crowd of people. This is becoming a very important aspect to public safety in general, and you can tie this into medical responses or even law enforcement related responses.
This first video demonstrates our implementation of a system which can detect and track people moving in a crowd. As you can see, the algorithm is not perfect and ends up missing people and falsely identifying unmoving objects, but it provides a proof of concept for a way to anonymously track individuals moving in a public area. This is done via a Haar cascade and a histogram of oriented gradients. The next video shows our idea for a way to catch anomalies. Here, one individual is moving the opposite direction as everyone else, and our task is to identify who the outlier is. We use a correlation filter using the minimum of sum of squared errors to track the person moving differently from the rest. These two systems combined demonstrate how something like this might be used to detect a cardiac arrest or other form of emergency.
After reviewing the work done by the group, we are on the right track in terms of getting the technologies developed and the type of work that needs to happen.